Yes, try as you may, you just can't get away from mathematics.
Thank you, Tom Lua, for that wonderful introduction, and welcome back. And I heard that you need to find the area of a rhombus, so once again you've come to the right place. The first question you might ask is, what is a rhombus? Well, a rhombus is a quadrilateral that has all sides equal. You can see here two examples of a rhombus with all sides equal. You may well ask, well, if the opposite sides are equal, are they also parallel? Well, you can say that the opposite sides of a rhombus are parallel. So this means that a rhombus is also a parallelogram and has all the properties of a parallelogram, but it's a special kind of parallelogram with all the sides equal. Let's have a look at some of the properties of a rhombus. As you can see here, this figure is a rhombus, and I'm going to move the point A, so no matter where I move the point, that figure will always remain a rhombus. So let's check out some of the properties. Of course, all the sides are equal. That's the definition of a rhombus. No matter where I move it, you can see that the sides are equal, so it's definitely a rhombus. If we look at the opposite angles, they appear to be equal. If I move this so I see another rhombus, then the opposite angles still remain equal. The diagonals are equal? No. However, I can move the rhombus so that when the diagonals do equal each other, you get a square. A square is a special kind of rhombus with the diagonals equal, but in general, the diagonals of a rhombus are not equal. Do the diagonals bisect each other? Well, you can see in this one, as we move it around, that the diagonals do in fact bisect each other. They cut each other in half, no matter where or what rhombus I have. Did the angles bisect the angles through which they pass? You can see that as I move this rhombus, no matter where I move it, the diagonals bisect the angles of the rhombus. And finally, we look at the diagonals of the rhombus and where they intersect. No matter what the rhombus is, those diagonals always intersect at right angles. A reasonable question to ask would be, if a rhombus is really a parallelogram, but a special kind of parallelogram, can't we find the area of a rhombus by using the area of a parallelogram formula? Well, remember, the area of a parallelogram from our last thing we worked out was the base times the perpendicular height. So in this case, you can see the red rhombus has sides of 5. So the base, if we were looking at this one here, would be 5. The perpendicular height, that is the line that meets the base extended at right angles, is 4.8. So using this formula, the area of this rhombus would be equal to 4.8 multiplied by 5, which is 24 square units. So we can see this formula works well, but there are other ways of finding the area of a rhombus. Sometimes you're not given the base or the side heights. Sometimes you're given the diagonal lengths. So there might be another way, and we're going to look at some other ways of finding the area of a rhombus. How about this? Look at this rhombus labelled ABCD. You can see it's divided by its two diagonals. The length of the diagonals are X and Y. Okay, if we just do some rearranging now, so rotating each of those triangles that the diagonals bisected into, we can see that once we've rotated those figures, we get the rectangle. So the area of the rhombus is going to be half the area of that rectangle. Well, to find the area of the rectangle, we use the length times the width. The length of this rectangle is y, the same length as the diagonal, and the width is x. So the area of this rhombus is going to be the area of the rectangle, which is x times y, but only half of it, so we multiply by a half. So according to this, the area of a rhombus is equal to a half times x times y, or half times the length of the diagonals. Here's another way of thinking about the area of a rhombus. If we take this rhombus here, we're going to cut up the sections and rearrange them. So let's see how we go. Okay, as you can see, we've taken the bottom part of the rhombus and rearranged them into a rectangle. Well, the area of this rectangle is going to be the length, which in this case was x, that is the length of the diagonal, and then multiply that by a half of the length of the other diagonal, which was y. So the area is going to be a half xy, or a half multiplied by the two diagonals. If you recall, before we had this rhombus and we worked out the area by using the parallelogram formula. So let's see if our new formula works. So our area of a rhombus is a half multiplied by the two diagonals. So in this case, or in formula, x times y. So in this case, looking at the length of the diagonals, we have a half multiplied by the length of this diagonal is 8, multiplied by the length of this diagonal, which is 6. So working that out, we get a half of 8 is 4, and 4 times 6 is 24 square units. Remember, that was exactly the same as the answer we got when we used the parallelogram formula. So to find the area of a rhombus, we've seen several different ways of approaching the formula for the area. We can, if we're given the base length and the perpendicular height, we can use the area of a parallelogram formula, because really a rhombus is a special kind of parallelogram. However, we've also seen for a rhombus, we can find the area by using the length of the diagonals. So the area of a rhombus is given by a half multiplied by the length of the diagonal. So if this diagonal is length x and this diagonal is length y, the area is a half multiplied by x multiplied by y. Thanks for tuning in.